Hi, scholars, and welcome back to our next lesson. Today we are looking at Unit 8, Lesson 7, and we are going to be looking at the area of compound figures on a coordinate grid. Before we jump in, these should feel very familiar. You are going to need a piece of paper and a writing utensil, as well as your classwork in Google Classroom. Also, please make sure you are in a distraction-free zone and your phone is away. Pause the video now and make sure that all of these things are true before we dive in. Great. Before we dive into today's lesson, I just want to frame where we've been in the unit and where we are going. We have learned how to find the area of basic shapes such as triangles and trapezoids, and then we looked at how to find the area in general on a coordinate grid. Today we're taking that one step further to more complex figures where we're going to need to use a new strategy in order to find the area. We're almost at the end of our unit, so a lot of the problems we're going to be solving today and in future days are going to be multi-step complex problems. And I know you all are up for the challenge. With that, let's dive in. I want you to think throughout this whole opening the following thinking question. How do I find the area of a compound figure? Specifically, we're going to look at this question, which says, determine the area of the figure drawn on the coordinate grid. Explain the strategy that you use to determine the area. The first thing I look at when I see this shape is this does not look like a shape I know how to find the area of. This is not a rectangle, it's not a square, it's not a triangle, a trapezoid, or a parallelogram. So I need to do something different in order to find the area of this figure. As I look at this shape, I see that I could actually split this shape into two. And what that then gives me is two rectangles. That's helpful to me because I have a formula in order to find the area of a rectangle. What I just did is called decomposition. And you can see the definition on the screen. It says splitting a figure into smaller known shapes that do not overlap. Notice how my two rectangles here, rectangles A and B, do not overlap. However, rectangles A and B together make up the entire figure that I originally had on my screen. Today, whenever I split up a shape, I'm going to be using the vocab word decompose, because now you should be familiar with what it means. Now, I'm going to use what I learned yesterday in class in order to find the area of each of these rectangles. So I could use absolute value. I could also count on the grid. So when I do that, I see that rectangle A has a length of 7, and rectangle A has a length of 8. Rectangle B has a length of 7 and a width of 4. You guys can take it from here, pause the video, and take 30 seconds to find the area of each of these rectangles. Now that you've had an opportunity to find the area of each of these rectangles, I want to go back to what the question originally said. It said determine the area of the figure drawn. So if I have the area of each of my rectangles, what do you think I'm going to need to do to both of those areas to find the total area? Pause the video and your teacher will ask one of you to share. That's exactly right. We need to add together our two areas. So check your work with mine. I got 56 square units as my area of A, 28 square units as my area of B, and when I added those together, I get 84 square units, which is the area of this entire rectangle. Take about 10 seconds to update your work now. I want us to now look back at our original shape. We split this shape vertically by drawing a line to create rectangles A and B. There's another way we could also decompose this shape. My question for you is, would decomposing this shape in a different way give us the same area? What if instead of drawing that vertical line, I drew a horizontal line like this to get rectangles A and B? Do you think that we're going to get the same area by decomposing this in a different way? Pause the video and your teacher is going to ask you to vote if you think yes, we will get the same area, or no, it will be different. Now that you've predicted what we'll get, let's actually solve. You guys know how to do this, so take 1 minute to pause the video and find the area of our new rectangles A and B, and then find the total area. Now check your work with mine. You can see my dimensions of 7 and 4 for rectangle A and 14 and 4 for rectangle B. As you can see, I got 84 square units, which was the same area I got when I decomposed the shape vertically. That tells me that there might sometimes be multiple ways in which I can decompose a figure. The most important part is that I decompose it into shapes that I know how to find the area of, and that my shapes are not overlapping, because then I would be double counting some of the area. I asked you a thinking question at the start of this, which was, how do I find the area of a compound figure? What do you think is the answer to that question? Take 20 seconds to write down what you think our key point for today is. If you wrote something similar to this, you were right on track. It says, the area of compound figures can be found using decomposition. Pause the video and make sure you get this down in your notes. Now that we are clear on our key point and we've learned how to decompose into rectangles, we're now going to do one more problem together that shape is a little bit tricky. You see the shape on the screen and the question that says, determine the area of the figure A drawn on the coordinate grid below. I first realized that this is not a shape that I have an area formula for. So I know I must use my key point to decompose this figure. By the looks of it, I think I might be able to make triangles out of this figure. So I'm going to actually decompose this figure by drawing that line across the bottom. Now you can see I have triangle A and I have triangle B. That's helpful because I know how to find the area of a triangle. I know that the formula for the area of a triangle is 1/2 times base times height. In a second, I'm going to ask you to pause the video. You're not finding the area yet. The only thing I want you to do is determine what are the base and height of each of these triangles. Write those down in your notebook in the next 30 seconds. Go. I want you to look at a place where I identified the base and height. I didn't write any numbers, I just wrote where these values are. My question for you is, do you agree that I correctly found where the base and the height of each of these rectangles is? Your teacher's going to pause the video and ask you to vote. Do you agree with these bases and heights? If you disagreed, you were exactly right. These were wrong places to write base and height on my triangle. Remember, our base and our height must be perpendicular. So I actually needed to draw extra dotted lines into my figure to show that vertical distance. So my base of triangle A is on the bottom, and you can see it's also the red line on triangle B. And then my height for each is represented by this dotted line, which is the vertical distance between my base and where the third point of my triangle is. Now that I've labeled where each of these is, I can count on my grid how long each base and height is. Then I can substitute into my formula to find the area of each of these triangles. Go ahead, pause the video, take 1 minute to find the area of triangle A and triangle B. Check your work with mine. I got 14 square units for triangle A and 3 square units for triangle B. If you answered 28 and 6, you forgot to multiply by 1/2. Remember, anytime we're finding the area of a triangle, we need to multiply 1/2 times base times height. Am I done solving this problem? Your teacher's going to ask you to vote. Yes, this is my final answer, or no, we still need to do another step. If you said no, we are not done solving, you were right. We forgot our last step of adding our areas together. Remember, the question said to find the area of the entire figure. So if I add 14 and 3, I get 17 square units. Remember, our units need to be squared because we are finding the area. We just applied our key point to this problem because we decomposed our compound figure into two familiar shapes that we could find the area of. Remember, the shapes we know to find the area of are rectangles, triangles, parallelograms, and trapezoids. So look for those shapes in your compound figures today as you're solving your questions. Before I send you off to work on some independent practice, I want to review our CFS for top quality work. First, annotate your problem. Second, it says figure is drawn accurately. This actually will be done for you so you can just focus on decomposing and finding the area. Figure is decomposed and dimensions are labeled. Formulas are written. All calculations are shown, neatly organized and labeled. And lastly, answer statement is provided. Make sure you include units on your work today. All of your units will be squared because we are working with area. That is it for our video today. I'm excited to see how well you guys do on your practice and excited to see you in our next lesson where we'll solve even more complex figures. Good luck with your practice today.